Hey, what's up, guys? So, um, this video is going to deal with uh, graphing equations using something called standard form. So we're going to get into that in a little bit, but before we get into that, we really want to talk about x and y intercepts, okay? So if we think about it, the word intercept means where two things collide, where two things connect, where they meet. One of the things you could think of is one of the first ever police cars was called an interceptor because cops, their whole job is to intercept the bad guys. So that's kind of how I remember two things that intercept, or where things intercept is where two things meet. Okay, and if we're talking about a graph, or we're talking about a Cartesian coordinate plane, we actually have two types of intercepts. We have x-intercepts and we have y-intercepts. Okay, so as you can kind of think, or as you kind of can tell, an x-intercept is where the graph, or the line, crosses the x-axis, okay? Because anytime a graph or line crosses the x-axis, there is an x-intercept, okay? So if you look here, our red line has 1, 2, 3, 4 x-intercepts because it crosses the x-axis at 4 parts. So likewise, the y-intercept is where the line, well, I should say where actually, where the line crosses the y-axis, okay? It's the point on the graph where the line intercepts or crosses the y-axis. X-intercept is where the line crosses the x-axis. So if we're looking at our red line, we only have one y-intercept, and it's actually down here at -2. Okay? One of the things that's special, or one of the things that's nice about our x and y-intercept is that the coordinates are very, very unique in that for x-intercepts, they always follow a certain pattern. For y-intercepts, they always follow a certain pattern. So let's actually just go to our x-axis, okay? What I want to do is I want to start at our origin, which is right here, dead smack in the middle, okay? Again, the origin, the coordinate of that is 0, 0. And again, that's our origin. Okay? So if we're going from our origin and we go along the x-axis, if you notice, we're not actually going up or down at all, okay? So if we just go left and right, the y value that corresponds with this whole x-axis is always going to be 0. Because as long as you don't go up and down, you just go left and right from the origin, you change your x value, but the y value stays the same, okay? So your x-intercept is always your coordinate, that is a number, 0, because it's where the line intercepts the x-axis, okay? Likewise, if we're at our origin and you stay along the y-axis, you're just changing the vertical number, okay? You're not going left or right at all, you're just going up and down. So if we notice, likewise, similar to the x-intercept, our y-intercept follows a nice pattern, is that we always have a y number, but the x value is always 0, because as long as we're on the y-axis, it goes through the origin, and it does not go left or right at all, it just goes up and down, so your x value is 0. Okay, so x-intercepts where the line crosses the x-axis, it always follows the trend that it's a number, 0, and the y-intercept follows a pattern that it's 0, a number. Okay, so let's just see here. We're going to talk about something called standard form. Okay, and standard form is the way that we graph equations, linear equations, using intercepts. Okay, and the standard form is ax plus by equals c, where a, b, and c are all integers. Okay, when you have something in standard form, you're actually not allowed to have fractions, which is why they're all integers. Okay, if you ever see an equation in this form, you're going to graph it using intercepts. Okay, but sometimes what people like to do is they like to give you an equation That is not in standard form. Okay? So if we look here, we have y equals 3x minus 2. Okay? In order for this to be in standard form, we need our a and our x to be on the same side. So what we want to do to solve this equation to be in standard form is we want to move the 3x to the left. Okay? The way you move it to the left is you just do the inverse of what it is. So if we have a positive 3x, we subtract 3x from both sides. We get negative 3x plus y equals a negative 2. And there we have it. We have a nice equation in standard form. Okay, so standard form, just to recap, is the way we graph equations using intercepts, and it follows the form ax plus by equals c. All right, so what we want to do here is we have a graph on our, we have a line on our graph, and we want to be able to identify the x-intercepts and the y-intercepts, okay? It's literally simple as going to your graph and just finding where the line intercepts the y-axis, where it intercepts the x-axis, okay? The thing you have to remember, though, is that your answers for x-intercepts and y-intercepts is always going to be in a coordinate pair. So, for instance, the x-intercept, we'll look here, we start at the origin, we go over 1, 2, 3, 4. So the x-intercept is at an x value of 4. And remember, the x-intercept always has a y value of 0 because we're not moving up or down, we're just going left or right. And likewise, to get the y-intercept, we go 1, 2, 3, 4, 5, 6, 7, 8, 9. We go up 9, so it's going to be 0, 9. All right. The x-intercept is 4, 0. The y-intercept is 0, 9. All right. Hopefully that's pretty straightforward. We'll just look at another one. Okay. Again, the x-intercept. It's where our line crosses the x-axis. So I'm going to go to my origin, go down 1, and we're at, or no, that's a y-intercept. So it's actually 0, -1 because we're to go down -1. Okay, and our x-intercept, we're going to start the origin, and we're going to go 1, 2, 3, 4, 5, 6, 7, 8. It's actually right here, the line's just a little big. So we know that our x-intercept is -8, since we had to go in the negative x direction, comma, 0. So the x-intercept is -8, 0. The y-intercept is 0, -1. All right, moving on. What we're going to do here is we want to be able to graph an equation from standard form and graph it on a coordinate plane. The opposite between this problem and the last two is that in the last two problems we had to find the x-intercept and y-intercept given the line of the equation. Now we're going to be given the actual equation of a line, and we have to find the intercepts before we can actually graph it. Okay. The way you find intercepts, if you're given the equation of a line, goes back to the definition of the x-intercept and y-intercept. Okay, the x-intercept always has a coordinate of a number, comma, 0. Okay, so the solution for your equation is always a number, comma, 0. Okay, for the x-intercept. So what you want to do to find your x-intercept is you're going to take the number 0, substitute that in for y, and then solve for x. Okay. So all I'm doing is I'm substituting a 0 in for y to solve for x because we know our x-intercept has a y value of 0. Okay, so that cancels because 0 times anything is 0. We're left with 2x equals 10. We'll divide both sides by 2. And we know that x is equal to 5. So again, what you must do is you must write your x-intercept as a coordinate because intercepts are coordinates because they're spots on a graph, okay? So we know that x is equal to 5 when 0 is equal to y, or when y is equal to 0. So that's your x-intercept. Likewise, the way we find our y-intercept, we know that the y-intercept always has a 0 value for x, so we can substitute 0 in for x and solve for y. Okay? So we can get 2 times 0 plus 5y equals 10. We know that 2 and 0 is 0, so we get 5y equals 10. Divide by 5. divide by 5, and you know that y is equal to 2. Okay, so your y-intercept is going to be 0, comma 2. All right. Now we know that in order to graph a line on a graph, we must have 2 points. So our first point is 5, comma 0. 1, 2, 3, 4, 5. Our next point is 0, comma 2. Okay. Now that we know our 2 intercepts, we can just, or now that we know 2 are intercepts, we can just graph the line. Okay. And there's the graph of 2x plus 5y equals 10. Okay. So the process to graph an equation in standard form is you must first find your x-intercept, then you must find your y-intercept. You have 2 points, and you can graph them. So again, I'll just do this one pretty quickly. We know that the x-intercept has a y value of 0. So it's going to be negative 4x plus 5 times 0 equals, why is this pen not working? Equals negative 40. Okay, that's going to cancel. You're going to get negative 4x equals negative 40. Divide both sides by negative 4. Divide by negative 4. And we know that x is equal to a positive 10. All right, so our solution to this is that when y is 0, x is 10, aka that's our x-intercept. Again, we want to find the y-intercept, so we use the fact that we know that when the y-intercept occurs, your x value is 0. And this pen doesn't want to work tonight for some reason. So we have negative 4 times 0 plus 5y equals negative 40. Negative 4 and 0 is 0. 5y equals negative 40. Divide both sides by 5. And you get y is equal to negative 8. So our y-intercept is 0, comma, negative 8. So again, all we have to do to graph that is first we're going to plot our 2 points. So we're at 10, 0, which is all the way over here. 0, negative 8, which is all the way down here. Okay. Then to just create a line, you just connect the 2 dots. And this one's orange because I didn't change the color. Okay. But there's our line. There's the equation, negative 4x plus 5y equals negative 40, graphed on a coordinate plane. Again, the process is always the same. To find your x-intercept, you substitute 0 in for y, solve for x, because the solution always has a 0 in for y for your x-intercept. Then y-intercept, you substitute a 0 in for x, because we know that the x value of your y-intercept is always 0. Solve for y, plot your 2 points, put it on a graph. Okay. One of the things that I want to go over now, though, is just how intercepts can relate to word problems. Okay. So let's say that we have a graph here that talks about the money spent on homecoming, okay? And our y-axis talks about the cost, and the x-axis is number of tickets sold, okay? Because as the cost, or as the number of tickets increases, aka our x value increases like this, the cost is actually going to decrease. Okay, let's say that each of these is $100. Okay, so that's 100, 200, 300, 400. Okay, let's say this is 500, 600, 700, 800, 900, 1,000, 1,100, 1,200, 1,300. Okay, and I'm just going to go 14, 15, 16, 17, 18, 19, $2,000. Okay, so if we're up at this value point right here, we know that the cost is 2,000. Okay, so again, for the number of tickets, let's say each one of these is 5, so there's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, and then 110, 120, 130, 140. Okay, so let's say we actually have this red graph, all right, here. Oops, I want red, not blue. Okay, and I'm making it extend off of our graph just so we can kind of see the purpose of this. So now let's say this is our graph to talk about the relationship and the cost of homecoming. So for instance, if we're just finding our intercepts, our x-intercept, okay, is all the way down here. Okay, down here, where the y value, like always, is 0, and the x value is 140. Okay, the hardest thing that kids have with word problems is being able to take an answer like 140, 0 and turning it into words. Okay, but the good thing you really want to look at is, what does our x value actually mean? Okay, well, the x-axis in this question is the number of tickets sold, where our y-axis is the cost. So this solution says that if 140 tickets are sold, the cost of the dance would be $0. Okay, that's the interpretation of the x-intercept. That's taking the really math of it, like the real math of it, of knowing an x-intercept is 140, 0, and relating it to a real life situation. Okay, and that's one of the things that they love to do on standardized tests. They love to take little ideas such as this and make you explain it in words. So similarly, we can look at our y-intercept, which is all the way up here at 2,000. So our x is 0, and our y is 2,000. Okay, and again, in words, what does that actually mean? Well, the x value corresponds with the number of tickets sold. So if 0 tickets are sold, the cost of the dance will be, well, $2,000. Okay. This whole idea of being able to take a simple, easy line on a graph and converting it to something that's real is very important, because this is where the whole deep connection and the really deep understanding of the math becomes apparent. So hopefully you guys understood this. If you have questions, let me know. There's going to be some problems for you to work on. Make sure you ask questions. Make sure you're really taking notes of these videos, not just watching them. You're actively learning.